what it says on the board. Okay, my point isn't just to teach you about density problems today. It's to teach you how to solve any problem. And I'm going to show you a method that you could use. Same as I did with metric. I want you to think back to metric a second. This is from the last couple of days. I know there's an easier way to teach the metric system. I could have you just count how many places and move the decimal place. That's the whole point of the metric system being on base 10. But I taught it to you using conversion factors because I know you're going to see them again. Same thing's true with density problems. Density problems are awfully easy. What's the formula for? You've already done one in a previous lab. What's the formula for density? Ooh, look at that. That's what you're going to be doing in Chem 2. Yeah, that's scary. Everybody knows the formula for density. I'll write this down. Is density equals mass over volume. And without giving you a hint, without saying a word, I just gave that to you on the worksheet, gave you the formula there, the lab you did a couple of days ago on significant figures, and you were able to do it and got the right answer almost entirely. The only thing you did wrong maybe was significant figures, because that's what I was grading you on. But you could do this without this method, because this method is going to, again, be a system that you could use to solve anything. Here's the problem. D equals M over V is not a very complicated formula. You are, in physics already, you have any formulas in physics yet? What'd you get so far? What formulas? What's that?
VF squared equals VI squared.
V, what's squared? VF squared equals VI squared plus 2AB AD. Okay? And in my class, you're going to get, plus you're going to get F equals ma, and the A, the acceleration, can be calculated. That's force equals mass times acceleration. You're going to get formulas for energy, like 1/2 m. I forget what is the formula for energy. 1/2 mg. I forget too. In my class, I'm not physics though. V2 P2 over T2 equals V1 P1 over T1. You're going to get P V equals N R T. These are much more complicated formulas. And you can't just plug and chug like you could with a very simple one like this. So I'm going to give you a system that you could use to solve any formula, any problems, physics, math, chemistry, biology, any of those. Okay? That's what I want to show you today. I'll let you practice a little bit, and then in the second half of the class, we're going to do a lab on it. And of course, I'm going to use density to show it to you. First thing you do, write down the given information. Again, once again, the first step, anybody can do. It's very simple. Believe it or not, people, this turns out to be probably the most important and the place where most people make mistakes. Hard to believe. What do you mean? How do you make mistakes just picking out the given information? Can't really screw that up, can you? You can when you're talking about V1 versus V2. Like you were doing with physics, initial versus final velocities and stuff like that. And for me, initial and final volume, pressure, temperatures, it's going to get tough. And you got to pick out the right one. So that's the first step. Write down the given. Let me give you all three steps, then we're going to do some examples. Second step, you find a correct formula. Whatever that formula is, F equals ma, PV equals nRT. You find the formula that relates the variables you're looking for together. The variables you're either given and looking for together. So much of learning, people, you have to get out of your head. I've tried to make this point about 100 times already this year. Isn't memorization, but rather being able to apply something. Mr. Schrader will give you a formula card that by the end of the year you will have filled up. You can make your own formula card, and at the end of the year you can use it on the final. Matter of fact, if you take the AP exam, I think in physics, if you take it in chemistry, they give you pages of formulas. They don't want you to memorize. They give you the periodic table. They don't want you to memorize it. They want you to be able to apply it. This is how you apply it. You pick out of that word problem the given information. You find a formula that makes sense with that information, and then you rearrange that formula. That's where the algebra comes in, and you solve it. So that's it. Those are your three steps. Let's apply that to these problems. I'm going to do 3 problems on the board right now. You can use those 3 steps to solve anything in chemistry, physics, science, math, anywhere. And you should use those. All right, let's start with first example. Start with a really easy one that pretty much anybody could probably look at and tell me what the answer is going to be. But I'm going to start with an easy one because I want to illustrate the process. Who can tell me what the actual answer is going to be? Anybody figure that out right away? What do you think? What do you think?
0.5.
0.5. The answer is going to be 0.5. It's going to be 0.5 grams per milliliter. You can probably see that because you know the formula for density is mass over volume. All right, and there's your volume, there's your mass. Beautiful. Okay? But let me show you what you're going to be doing, not just today, tomorrow, and the next day, but the rest of this year in order to get full credit. Remember in the last worksheet I gave back to you, last lab I gave back to you, the significant figure lab? Over to the side, I had you write down, I had formula calculation for the sum, calculation for whatever. And I told you, I think when I gave this back to you yesterday, no one did that right. I did not take off for it. But no one did what I wanted you to do for those. Most of you thought I meant show me the longhand addition, the longhand multiplication, the longhand division. It's not what I wanted. What I want is exactly what I'm going to write right here. I want you to write down the given information, find the formula and rearrange it, and then plug it in and solve it. I don't need to see longhand multiplication. You have a calculator for that. All right, so let's write down the given information. I have, in this problem, D, M, and V. So I write that down to the side. The Department of Motor Vehicles. Don't want to go there. DMV. You'll be waiting in line. Anybody go for their permit tests yet? Then you know what I'm talking about. Scary. All right, what's your density in this problem? Read the question. What's the density in this problem, Mariah? 10. 0. 10.0. 10.0 milliliters. Okay. What do you think, Gavin? It's the unknown. Read those first two words, Mariah. Find the density. All right. See, what did I say? I didn't set Mariah up there. I didn't say, hey, Mariah, make sure you. I didn't say tell me the wrong answer. It absolutely happens. The number one mistakes you're going to make are going to be in this first idiotically stupid step. Okay? And that's what happens. And it's not going to be just Mariah that does it. Because everybody does it. Here's what you're so used to doing. Exactly what she did. And the reason you have such trouble with word problems. The reason you have trouble with word problems, you just read left to right. First number I come up with, I'm plugging it in. First number I come up with is going to be the thing. No. You got to read it. What's my mass in this problem? By the way, reading meant find the density. That's my unknown. What's my mass in this problem, Lexi?
5.0 grams.
Good. She didn't just go left to right. 5.0 grams. Now, how'd you know 5.0 grams was the mass? Because it said it was the mass. The mass is 5.0 grams. What if it didn't say that? How would you know 5.0 grams has to be a mass from something we did earlier in this chapter? How would you know 5.0 grams has to be a mass because of something we did in this chapter, Kyle? The units are grams. If I tell you I'm 6'2", I do not have to say to you, my height is 6'2". You understand that 6'2" is talking about my height, not my weight, right? If I say something is 10.0 milliliters, it never said the word volume up here, did it? But you know 10.0 milliliters goes under volume. Okay? So there's your first step. And again, yes, I'm being an idiot and taking more time than I need to show you this so that you are not memorizing your way through something, but rather thinking about it. Second step, got to find the right equation. Well, here's where this chapter makes it real easy. There's only one equation we're using. What is it? D equals M over V. That will not be the case when we get to gases. When we get to gas laws, there'll be multiple possible equations you can use. You have to figure out which one applies in this case. And sometimes that's confusing. Okay? And here, it's not. By the way, rearranging and solving. Do I need to rearrange this, or is it already set up the way it's supposed to be? Yeah, I'm good. So I just plug them in. 5.0 grams over 10.0 milliliters. And I get, as I forget who answered originally, the answer we knew we were going to get, 0.5. But if I leave it like that, I've got a couple of problems. I have a couple of problems. What's wrong with that? Why am I going to lose some points on this? What do you think? I only have one significant figure, and he should have two. So it should be 0.50 gram. 0.50. What's the second mistake, Maggie? I have no units. Grams per milliliter. Okay? Because grams and milliliters, neither one cancels, so they're still there. Grams per milliliter. And there you have it. That, in a nutshell, is what I want you to show me on every time you see a problem that's going to be any problem, but in this chapter, the density problems, that's what you need to show me. The work written, or the information written down to the side, the formula, rearrange if you need to, and then the answers. Now, this seems awfully simple. Most of you guys, or all of you guys are in an honors class. You didn't get here by not being able to solve a problem that easy. Let's do another one. Make it a little bit harder. Okay? Try that one. Write that down. Find the mass of 0.025 liters of a substance if its density is 5.0 grams per milliliter. I'm going to do the same thing. Write down the given information. So let's see who could tell me what to write down first here. Zach, what should I write down for the density?
5.0 grams.
5.0 grams per milliliter. Is everybody good with that? Okay? Because it says the density is 5.0 grams per milliliter. How about the mass, Savannah?
It's unknown.
Find the mass. It's the unknown. Very good. What about the volume, Ethan?
0.025.
0.025 liters. All right. Very nice. Another reason why this first step is so important. This time, nobody picked the wrong guy out because you read. And you didn't just go left to right, first thing I ran into. But you still have something else to do. Does anybody see what it is? What is it, Gabe?
Liters and milliliters.
Yeah, I got the same quantity being measured, volume in this case, milliliters and liters, but using different units. I can't do this problem the way it is. Kind of like this. I use this as an example. Don't write it down. 2 feet minus 4 inches equals negative 2 feet. Does that make sense? If you take away 4 inches from 2 feet, is that what you get? Well, 2 minus 4 is negative 2. Isn't that right? Obviously not, because inches and feet. I can't do the same. I can't have, in the same operation, different units for the same quantity. I've got to be able to change them to the right one. Now, which one would obviously make sense to probably change? What do you think I should change? That would be a little bit easier to change. What do you think, Gavin? Should I try to change the milliliters that's at the bottom of this guy, or should I try to change the liters that's there? You think it's easier to change that guy than it is to change this guy by a metric conversion? Have you never done one like that before? Where you had a unit? Did I give you anything like that in metric conversions? Where you had 5.0 grams per milliliter and I asked you to change just the milliliters? Or did I give most of them that would look like this and you had to change it to liter? Yeah. I would want to do this mostly. I could do that one. It's not impossible. It would use the same basic logic. But if that's the one, that's obviously the way I've been setting them up for so long. It's pretty easy to do. All right, what am I going to do? Well, how would I do it? Hey, notice what we're doing here? Notice what we're using today? I'm using prior knowledge that I've been teaching throughout this chapter. I have to do a metric conversion, which I spent the last couple of days teaching you. I gave you a worksheet on yesterday, and you all did. I'll give it back to you today. Liters go on the bottom. Milliliters on the top. Who's bigger, a liter or a milliliter? So he gets the 1. And milliliter means 1,000. So therefore, my volume is going to be, my volume is going to be what? 3 zeros, making them bigger, what? 25 milliliters. This is another reason why I don't really worry about going over the homework all the time. Okay? If you're in one of my classes, I teach something, it's not like, oh, that's the last time you're ever going to see it. You see it, did I just, in the last problem, do significant figures? We were doing them last week. I'm doing here now metric conversion. We did that last 2 days. All right? So it's not like it goes away. Chemistry keeps using this stuff over and over again. I don't have to go over every single homework problem to be able to review this stuff with you. I'm going to review it the very next day anyway. All right. My next step. That's only the first step. I told you the first step, believe it or not, is the hardest. You had to pick out the right stuff. You had to make your conversions so they're in the right units. Now the second step is the equation. D equals M over V. The only equation we have, so you can't screw that up. However, he's not set up properly this time, is he? What do I have to do? Let's use some algebra here. Very simple algebra. D equals M over V. I want to solve for M. What am I going to do to both sides to get m by himself, what do you think, Eric?
Multiply by v.
Multiply both sides by v. Does everybody see why? I got to get rid of the v. He's down here, right? Multiply both sides by v. What do I get? M equals v times d. Correct? So m equals, my v was 25 milliliters, and my d was 5.0 grams per milliliter. Got it? What's my final answer for this guy? What is my mass? What's my final answer? Get your calculator out if you have to. I don't think anyone should have to. You have 5 quarters in your pocket. How much do you have? All right. So I'm going to write down 125. What's wrong with that? Do not write it down. What's one thing that's wrong with that? What do you think?
Wrong number of significant figures.
Wrong number of significant figures again. He has 2, he has 2. How many does he have to have? 2. Yeah. Isn't this annoying? You can't ever, for the rest of your life in this class, and theoretically, if you take any other science class, you can't ever just plug 2 numbers in or even do them in your head and write down that answer. You've got to always think about the measured numbers that came before him, and then put down the correct answer. So it's not 125. What is it? How many significant figures did he have? 2. 2. He has to have 2. So I know. I'll round that guy up and it becomes 13, right? 130 is correct. Why not 13? What did you do if you made him 13? It's only 2 significant figures. I did it right. I got 2 significant figures now. What's wrong with 130? Because I want to play poker with you, right? Remember that analogy? If I owe you $125 at the end of the night, you're going to take 13? No. Okay. Finally, it's still wrong. What else do I need? But yeah, look what happens. Milliliters canceled leaves me with grams. And there's my answer. Okay? Last problem. You ready? Copy that guy down. All right, so this time I'm told I have 41.5 grams of the substance, and I told its density. All right, let's set this guy up. You ready? I have to erase that guy over. Yes, over here. Okay. And we'll set that everything same way. V, M, and V. Now that we've done 2 other examples, this is the last one I'm going to do, and I'll let you work on some problems. Should be getting like second hat to us. Old hat. Not second hat. Second hat? Old hat. Whatever. What's the D in this problem, Maggie?
41.5.
Oh! Mariah, tell her what's wrong with that. What did she do? She did the Mariah mistake. And someone will make it all day long. Isn't that amazing? Isn't it amazing? Yeah, you can't just read left to right. You got to read what it says. 41.5. It's kind of another analogy. Okay? Well, no, I already used that one. That's okay. You got enough. You know what I'm talking about. Grams per milliliter, 2.8. I like analogies. All right, 2.8 grams per milliliter is the density. What's the mass in this problem here? Alexis? 41.5 grams. And my volume is what in this problem, Josh? The unknown. All right, let's do the equation now. The equation is D equals M over V. Everybody, I've done this before. I'm going to walk around. I do not want you to plug numbers into this. I want you to rearrange that algebraically and tell me what you get for V in terms of M and D. What does V equal? Just in terms of M and D. Okay? Do that. Rearrange it right now. Everybody. I'll walk around. I want to see what you guys get. Say, well, I don't know. This is simple algebra. Let's see. Let's see how well we do. Rearrange this problem. You don't need a calculator. I want only V in terms of M and D. So V is either going to be M times D, D over M, M over D. That's what I want. Everybody got it? Okay. Oh, sorry. That one there. Okay. There you go. All right. Okay, I've seen all possible answers at this point. And I'm seeing, to my surprise, more correct than incorrect, which is actually good. Where's yours? However, I'd say approximately a third so far of what I've looked at, although these are pretty good too. Right? Well, I can't see everybody's, but I would say, well over half got it right. But the people who didn't, maybe 30% of you who did not get it right, absolutely saw V equals M over D, V equals D over M, and V equals M times D. I saw all three of those. Okay? Just like I thought I would see. If this wasn't an honors class, I probably would have seen a lot more wrong. I've had classes where 2 or 3 people rearranged this correctly in the entire class. 2 or 3. In this class, it was about a little over half. What did you do wrong? Those of you who got it wrong. Let's take a look. All right. Well, here let's do it right first. Let's just do it right. D equals M over V. People want to just say, okay, I need to get V by himself, so I will multiply by M. Is multiplying by M going to get rid of M? What's it going to do? It's going to give you M squared. Okay, so I'll divide by M. And then they get, okay, great. If I divide by M, I get D over M equals V. And that is just not true. Because M cancel, well, you get 1 over V equals D over M. That's not what you were looking for. So those of you who got D over M, this one here, that's what you probably did. Okay? Let me show you how you correctly do it. And a lot of you are saying to yourself, by the way, right now, you don't have to do it that way. You can do it. You could do it a lot easier. I'm just going to cross multiply, or I'm just going to, rearrange them. You can for one guy this easy. What about that one you were doing in physics a second ago? VI, VDev plus 2AD. What about V2, P2 over T2 equals V1, P1 over T? Can you always just cross multiply and get that answer? No, you got to be able to use the rules of algebra. So here are the rules of algebra. V equals M over V. I need to get V by himself, but I also need to get him in the numerator. So I'm going to multiply both sides by V. Say, well, how does that help me? Because now I have V times D equals M. That doesn't help me. I don't want M. I want V. Okay, do a second step. What are you going to do to both sides now to get V by itself? Divide by D. So your correct answer is this. V equals M over D. How many had V equals M over D? Raise your hand. Told you it was over half, but there were a lot of wrong answers too. Okay? Probably about maybe 10 to 20% wrong. All right, let's erase these and finish it up. Now, once you have it set up, you do the last thing, whoops, and you plug in the numbers. M is 41.5 grams. D is 2.8 grams per milliliter. Okay? Get a calculator out. This one can't be done in your head. No one has 2.8 quarters in their pockets that are worth 41.5 cents. So you can't do it. By the way, you need to bring calculators every day. I told you what kind you should have or get. If you don't have them, and I notice quite a few people do not, this is the last week you're going to be borrowing them. Okay, after this week, because for the lab back there, when you go back there in a little bit, you can still borrow one. You need to have your own. Okay, it's not enough to say, well, I'll just borrow somebody's. You can't. When you have to do homework, you have to have it for home, too. Okay, divide those out. What do you get? Who's got an answer? Jen, what did you get?
15 milliliters.
She got, what did your calculator say?
14.8.
14.8 exactly, or well, a whole bunch of numbers after that, probably. Okay, well, whatever. She rounded it off to 15 because there's only 2 significant figures here, right? Does that make sense? Did everybody get 14.8, blah, blah, blah? Okay, so 15, and grams cancel, leaves you with milliliters. Got it? Okay. Everybody good with that? All right. Now, your homework is, I don't think I have it on the board here. No, I don't, but I'll write it up here. Page 50, number 69, 71A and C, 73 B and D, and 74 B and E. Okay. Couple of things about those when you're doing them, okay? I believe there's one or two where instead of giving you milliliters, it says this. Okay? What's that? How do you read that?
Centimeters.
Yeah, or cubic centimeters. You know where that comes from? You know what that's the same thing as? Cubic centimeters. cc's. Come on, all you druggies. Come on. What do you measure when you're shooting up? You know, heroin, cc's, right? cc's are the same as what? What, though? They're the same as milliliters. They're exactly the same thing as a milliliter. Okay? So you drug addicts should know this. How many cc's you got? You don't want to OD. You know. All right. Just kidding. No druggies here.